you very much. Thank you for coming. I have a short presentation because it's the first step of our study to improve the internal structure of 3D printing parts from extrusion deposition. So my name is Julien Garmand. I'm assistant professor. I'm assistant professor at the EPF Engineering School in France, and I research attached to UTT, University of Technology of Troyes. So I would like to present you a method to improve the fracture toughness using 3D printing by extrusion depositing. So first of all, I will begin by introduction with problematic and objective. Secondly, I will present use of FDM technologies of fused depositing modeling by 3D printing. Thirdly, the fracture tested by CT specimens, and we will finish by conclusion. So, as the EPF is established in France, to Paris, Troyes, and Montpellier. So, the fused depositing modeling is a 3D printing technology which works layer additive manufacturing process to realize a part. This technology uses a classical trajectory of thread, but it's not based on the specific mechanical constraints. As the objective is reproduce the possible direction of the stress in a standard crack test CT sample through the 3D printing by extrusion depositing. So we can see the research process. We begin with a 3D model. We realize the CT specimen. We use the numerical simulation to extract the principal direction of stress to reproduce them through the alternate slicing by 3D printing to realize a specific internal structure and study the mechanical behaviors. So the fused depositing modeling use filament. The filament is deposited to realize parts layer by layer. We can see the classical structure, a linear structure, and alternate layer to realize a part. So we reproduce the principal direction with alternate layer to reproduce the trajectory of depositing in 3D printing, and we translate each principal direction by G-code. It's classical G-code used through the CNC machine, but it's G-code is used through the 3D printing. And we realize mechanical testing, cracking test through CT specimen. So the routine condition, we use tensile machine to realize our cracking test is. We can see cracking branching is observed through this heterogeneous specimen. And we use a classical sample and optimized samples to compare them. We can see the first curves to observe the mechanical strength. We can see an increase by optimized printing on the right, and we compare them to analyze the mechanical behaviors. So we can observe its evaluation, the optimized CT samples have higher fracture strength up to 20% than classical samples. It's analyzed with two average of optimized sample and classical samples. And we can compute by the correct specimen define a new strategy to reinforce the specimen by specific fused deposit lines. And we reproduce the possible stress adduction from finite element, and we manufacture the CT specimen by extrusion deposition by 3D printing. And we can observe an enhancement of the fracture toughness with optimized trajectory. We are continuing the study with digital image correlation to analyze deformation fields of CT samples. And we can see the first test on the right. If you have I would like to show you just my prototyping laboratory with stereolithography. I have color binding jetting 3D printing. I have some technologies to realize 3D printing parts, and I work in a sustainable building in Troyes, in France. You can find Canadian well on the solar, in the roof, etc. Thank you for your attention. If you have any question, I'll do my best to answer them.